Hi. So I recently stumbled upon this book. It's called The Mythical Men-Month Essays on Software Engineering. Kind of a lengthy title, and so I started reading this book and I realized it was on management in software engineering. And even though I'm not a manager, far from it, but I still, there was a lot of things that I think are beneficial not only to managers, but also to the implementers, so to speak. So this book covers things like business side a little bit. It covers product management, it covers project management, it covers design, software architecture. It covers infrastructure, it covers programming, it covers a bunch of stuff. So I'm gonna read out the main ideas. They're not even the main ideas, but they're ideas that I found the most helpful to me, and they're the most helpful ideas for developers. So the first one is: the challenge and the mission are to find real solutions to real problems on actual schedules with available resources. So basically meaning that the thing that actually works is better than this ideal thing that just doesn't exist. And so if you try to take an ideal solution and translate it into the real world, that transition from the ideal world to the real world is gonna somehow change this solution, and instead of it being ideal, it becomes not ideal, but at least it becomes real. So the second, quite an important thought, is conceptual integrity is the most important consideration in system design. Conceptual integrity does require that a system reflect a single philosophy and that the specification as seen by the user flow from a few minds. So this means that a manager should ensure that the system is being built following one design. If, for example, there were people who were developing the system and they had this kind of design in mind, and then some other people changed them and they start to develop following some other kind of design patterns and whatnot, the conceptual integrity is compromised, it's non-existent, and the system is kind of, it just crumbles, because there must be conceptual integrity if you want a robust system. The next one is: the programmer, if stuck, can get unstuck by contemplating the data. Representation is the essence of programming. So representation meaning data in representation. Basically, all the programming is representing the data and then manipulating the data. So if stuck, you can kind of abstract away from the code and look at the data, and this will give you the answers you're seeking. The next one is: plan to throw one away. You will anyhow. Meaning that, sometimes, say you want to make some small project and you have it in your head, and perhaps if you have a lot of experience it will work, but oftentimes, even if you have a lot of experience, 20 minutes into implementing the project, you kind of realize that how could I even think this was gonna work? You had this in your head, but when you started to implement it, the reality kicks in, and you see all the things that you've perhaps missed or misunderstood, or just didn't think about at the moment. So it's always is that the initial design is not gonna be the final result. Some tweaks will be made, and the less experience you have, the more changes the initial design will have to go through. That also goes back to the first idea of the challenge and the mission are to find real solutions to real problems on actual schedules, is because if you try to plan everything and make a perfect plan, a perfect design initially, then you can have analysis paralysis. And the important thing is to get moving, and as you kind of go through the motions, you realize new things that you couldn't even think of before. So plan to throw one away, because you will anyhow. The next one is more pragmatic. It's paragraph comments over one-liners and self-documenting code. So meaning you combine documentation and the source code, which is like done. Basically, it's like a standard now. But what I mean by paragraph comments over one-liners is that, you know, you can have like one-line comments of like, open this file, and then in a couple of lines of code later, another comment like, extract this, close the file. Instead, paragraph comments, you put them in the beginning of a subroutine, let's say, and so there is like a prose documentation. So it's like opens file, extracts content, closes the file, or something like that. So you can see already kind of in one paragraph what the whole subroutine does, instead of going through the subroutine code and having one-line comments for each kind of couple of statements. And self-documenting code means that you give meaningful names to functions, classes, variables, to everything basically. And that's kind of how high-level languages work anyway, so that you don't need one-line comments. So the next one is buy versus build. The most radical possible solution for constructing software is not to construct it at all. So this basically means to take what's already there, to not reinvent the wheel, which makes sense, and it goes back to the first principle of making real solutions on kind of real schedules with available resources. Because of course, if you reinvent the wheel and you kind of optimize it for whatever problem you're solving, yes, this solution will be better than a generic one. But the problem is, if you're gonna reinvent all the wheels needed for the solution, then you might never finish it. Like, it will be too big of a task. So the most radical possible solution for constructing software is not to construct it at all. And the final one is incremental development. Grow, not build software. Meaning, you know, with agile development and all that stuff, you go through iterations of software. First, you create a minimal viable product, and then you get the system that is working, and it has the most basic functionality, and then you build on top of it, and on top of it, and on top of it. So instead of kind of building it as a kind of a building where you build it from the ground up, brick by brick, instead you're kind of growing on top. It's like a snowball, more or less. You have this core, you've built it, and then you add things on top, you add functionality. And with each iteration, the software is grown. Yeah. And that's kind of it. Hopefully you'll find these ideas as helpful as I've found them. It's important to sometimes get reminded of those simple ideas because they're basics for a reason. They're fundamentals, and if you have a strong foundation, you can build a lot on top of it and not worry about it all crumbling down. So yeah.